Okay, so let's start with UDP. UDP is connectionless protocol where you don't need to establish connection to the receiver side. Okay, so segments that are on the transport layer, are directly sent from sender to receiver or receiver to sender if they are using UDP. So there is no need for connection establishment. Okay, so let's see. So what are the basically disadvantages? Packet can be lost, not packet, because packet is on network layer. We are talking about segments in the transport layer. So segments in the transport layer are basically these are nothing but just these segments are a group of data or stream of bytes that is coming from the application layer is grouped into segments, and then a header for the protocol, maybe UDP header or a TCP header is added, and then the whole is called the simple, let me open up my Paint and then I can inform it to you. Okay, so suppose so there was bytes of data. Now this is data is coming from application layer to the TCP layer. So these bytes are divided into one segment. So this is one segment, okay, then another segment, okay, and then for each of the segment a header is added. So this is called header and this is called payload. Okay, similarly this is called header and this is called payload. So this is second segment, and then this segment is passed on the, so this thing is going on the transport layer. Okay, now this next process is after this one header is also applied. So this was coming from the previous layer. Now one more header is applied, which is IP header. This happens at the network layer. Okay, network layer. So it is having this header and payload of the previous layer plus, so this whole constitutes the payload at IP layer. Okay, this is the header of IP packet, header plus payload. Okay, similar thing happens and so on. Now if you have a look at this, so packets may be lost. No two packets can be delivered out of order. So segment can be delivered in the last, and last segment can be delivered in first. So there is no connection establishment is required. So it is fast actually, because it's three-way handshaking is not there. Secondly, UDP packet header is very small than TCP, and there is no congestion control. So the transmission is very fast, no handshaking, and all the UDP segments are handled independently of each other. For example, DNS. So DNS can use both UDP and TCP, but DNS actually can use UDP because what DNS do is it converts the www.google.com to the corresponding IP address. System knows IP address, we can remember google.com. So the translation from the text or the domain name to the actual IP address is done by DNS, and that query is very short, by very small text is there, right? Very short query is there, like you need to convert, so you need to convert google.com to IP address, so that's very short. So for this UDP can be used. Okay, so for small messages UDP is used. Secondly, but UDP is not reliable. So if data is lost, data can UDP segments can be sent from multiple paths. from source to destination, and those packets can also be lost. Okay, so it is used generally, it can be used for multimedia applications like video streaming. So in video you can see there are some frames that are lost, so it doesn't care, UDP doesn't care if data is lost. Okay, so it's unreliable. Now UDP source port number is 16-bit, so there are 2 to the power 16, that is minus 1, that is 6553 bytes of data at the max that can be there in the UDP segment. Okay, so in a UDP segment, amount of data is 0 to 65535. Similarly, destination port, which is also 16-bit. Now length in bytes of UDP segment, including the header. So length gives you the bytes that are there in the header, and checksum provides error control. We will see how. Now let's see. So length, suppose length says, okay, length is a 16-bit field. So if length says it basically defines the total length of your data. For example, 8 bytes of header. 8 bytes of header is compulsory in UDP, that is fixed, while in TCP you have 20 to 60 bytes of header, which is variable length. Minimum is 20 bytes and maximum is 60 bytes in TCP, while in UDP you have 8 byte of header. Now out of those 8 bytes, 4 byte is 2 byte is source port, 2 byte is destination port, 2 byte is length, and 2 byte is checksum. Okay, now length will give you the size of the segment, including this whole header. So if your suppose your segment was 16-bit, so this length will give you 4, that is length will give you 0 0 0, all zeros, plus 0 0 0 0 0 0 0 0, and then for 4 bytes or maybe for 16 bytes it will give you 3 zeros and then 1 0 0 0 0. Okay, so basically whatever the value is there in the length field, suppose it was all ones. Okay, so all ones means you need to do it 2 to the power that value. Okay, so that is the actual size of the UDP header. Okay, now this is the UDP segment format. So header here is having 8 bytes. You can see source port address is 16-bit, destination is 16-bit, UDP is 16, and checksum is 16. Now what is pseudo header? Pseudo header is the information that is collected by the segment at transport layer from the packet at the network layer. Basically sometimes, or maybe UDP header segment requires IP address to know IP address through the IP address of the machine from where and to where it wants to send the port. It needs a port. Port defines a process on the machine, but you also need to know the address of the machine, and that address is given by pseudo header. So pseudo header consists of those fields of IP addresses which are non-changeable. So every packet at the IP layer or the network layer is having certain values like source IP, destination IP. So these are non-changeable, these are fixed. So these values are taken inside the transport layer as a pseudo header. Okay, these values are taken from the IP layer to this layer as a pseudo header. Okay, and the variable fields cannot be taken here in the segment format as a pseudo header. Okay, now checksum. Why checksum? So checksum is basically the mechanism that provides the error control. For example, suppose you have some value. Okay, so how this checksum works? It basically adds all the 16-bit integers. So 16-bit why? So this is the first, you can say 16-bit and then 16 bits. Okay, so it will keep on adding those 16 bits. So treat segment contains as a sequence of 16-bit integers, and then checksum addition of 1 complements of the segment contents. What it does is, so suppose it was having 1 1 1 1 and 0 0 and all zeros. Okay, 0 0 0. So 12 times 0, and this was 1 1. And then first, so this is the first byte of your first 2 byte of your what do you call it? So first 2 bytes of your UDP header. Okay, now let's see. So okay, so some value 1 2 3 4 and some up to 16 bits, then 1 2 3 4 up to 16 bits, then 1 2 3 4 up to 16 bits. Suppose this was the size of your so I'm assuming it, actually it is minimum of 8 bytes. Okay, so I'm assuming it is 8 bytes only. Okay, so 2 byte and 2 byte. So this 2 byte would be having source port, destination port, and what? Source port, destination port. Third thing is 2 byte total length field, TLEN. Okay, so this is 2 byte and 2 byte. 2 byte from source port address, 2 byte from destination port address, 2 byte from total length. So 6 bytes, and then 2 bytes from checksum. Okay, so suppose this was there, 2 bytes from checksum. Now how will you calculate the checksum? So or maybe checksum, because checksum field is optional. So if it was not there, suppose 2 bytes of data over here. Okay, now what you will do is you will add all those values. Suppose you get 1 1 1 and remaining zeros. Okay, what you will do is now, so up to 1 2 3 4 5 6 up to 10 more, up to 16 times. Okay, so 16 zeros, right? So this was your total sum. Now what you will do is take 1's complement of this. So this was your first sum. Okay, sum. Now takes 1's complement. Okay, so you will get 000 and all ones, right? When you add these two, sum and checksum, okay, now what you will get? You will get all ones, right? So at the sender side, so there is a sender and there is a receiver. So this is sender and there is a receiver. So at sender side, what it does is it takes all the fields, calculate the checksum of these 2 bytes, first byte, second byte, third byte and fourth byte. So this is 16-bit line basically. So it will add all the 16-bit, take its sum, okay, and take its 1's complement. So first of all you need to add everything, 2 bytes, add all the 2 bytes, okay, whatever the sum value is outputted, what you will do is take its 1's complement and store this in the checksum field. Okay, the checksum field of the header, you will store it. Now at the receiver side, what it will do is it will send this segment as it is. Now segment is having checksum. Also it will calculate the sum of this again at the receiver side. Now sum plus checksum, if sum plus checksum is giving you all ones, then that would mean that there is no error in the segment that is delivered. So there is no bit is changed in the segment which is delivered. Okay, so this is a whole idea behind checksum. Now also if you are adding and you get a carry forward 1 over here, overflow 1, you will also again add this over here, right? Okay, so this is how the process of checksum works. So exactly that thing they are showing over here. So first what they will do is they will write it in the form of 16 bit, write every 16 bit, then 16 bit and so on. It will write all these values over here. It will calculate checksum, and then what it will do is it will save the checksum and take 1's complement, and on the receiver side the checksum value, that is 1's complement value, it will also again calculate the sum and compare them, add them. If all the values are 1, then that means packet is not corrupt. Okay, now question is, so there is one question: what is the source port number, what is the destination port number? UDP header is given to you in hexadecimal format. Header means 8 bytes are given to you. Now a hexadecimal means 0 in the hexadecimal means 0000, that is 4 bits, right? And 06 means 0000 and 0110, right? So total 8 byte. Now source port number, we know that source port number is 16 bit, right? So 0632 in hexadecimal, and if you convert it into decimal, what you will get? You will get this value 1586. Similarly, next 4 values 000D, these are the destination port number. Okay, so that is 13. Now third is 001C, and which is the total length of the user datagram. So 001C is 28. Okay, so 28 byte is the total size of the UDP segment. 28 byte is the total size. Okay, and 8 byte is the header size. Now what is the length of data? So that is 28 minus 8, so that is 20 bytes. Okay, clear? I think this example is clear. So that's all about UDP. We will start with the TCP in next class. Thank you.